Have you ever wanted to learn rocket science in 90 seconds? Great, let's go to the moon! First, to get to space and stay there, we need to go really fast upwards and then sideways. We'll enter an orbit, which is when gravity pulls us down, but we miss the ground because we're moving so fast. The speed we need to orbit at a distance from the Earth is given by this equation, and for low Earth orbit, or an orbit less than 2,000 kilometers above the surface, we need to go 8 kilometers a second. In reality, things like air resistance and gravity mean we actually need to achieve a velocity change, or delta V, of closer to 9 to 10 kilometers per second throughout launch. To get up to that speed, we'll need a rocket. It contains an engine, some fuel, and a payload. Rockets move by throwing out fuel opposite the direction they want to move in. The rocket equation tells us exactly how fast we can go given the amount of fuel that we have. It states that our change in velocity equals the speed at which we can throw out fuel times the natural log of the ratio between our total rocket mass and our non-fuel mass. Using this, we find that about 90% of our rocket's mass is just fuel, depending on our engines. So we just need to carry a lot of fuel with us, and then we'll be good to go. Okay, now we're in low Earth orbit. To get to the moon, we'll need a couple of principles from orbital mechanics. 1. Every orbit is an ellipse. Some notable features include A. Eccentricity, a measure of 0 to 1 of how narrow the ellipse is. B. Periapsis, the lowest point in the orbit. And C. Apoapsis, the highest point in the orbit. 2. Firing prograde, or along our direction of travel, raises the height of our orbit on the other side, and firing the other way, retrograde, lowers it. If we wait for the right time window, we can fire prograde to raise our apoapsis to intersect the moon in a so-called Hohmann transfer orbit, which will require a delta V of about 6 kilometers per second. Now we just sit back and wait to intercept the moon in 3 days. Now we're here, and to land on the moon, all we need to do is slow ourselves down enough and gently land on the lunar surface.